So the second part of our exponent rules are going to start off with power of a fraction. So if we look at part A, it's 3/5 that whole quantity raised to the third power. So we can think about it the same way we did before. We're multiplying 3/5 times 3/5 times 3/5. If we group the top, or the numerator, it will be 3 times 3 times 3. And we group the denominator, 5 times 5 times 5, then we know that we can really simplify by saying 3 to the third over 5 to the third. It's the same exact rule as we had before, where we're going to add our exponents to get our final answer. So let's take a look over here at part B. We'll do the same thing. C squared over n times C squared over n times C squared over n. We can regroup the numerator, C squared times C squared times C squared, over the denominator, n times n times n. So again, the same way we did before, we're going to add our powers. So it would be 2 plus 2 plus 2 on the top would give me c to the 6th over 1 plus 1 plus 1 on the bottom would give me n to the third. So if we think about it, I'm just multiplying each exponent on the inside by the exponent on the outside. So for here, 1 times 3 is 3. 1 times 3 is 3. Over here, we have 2 times 3 gives me 6, and 1 times 3 gives me 3. So let's make a rule. If I have a fraction, a over b to the x power, that's going to simplify to a to the x power over b to the x power. If I have a fraction that already has exponents, let's say a to the y over b to the z, that whole quantity to the x power, that is going to simplify to a to the xy over b to the xz. Next, we'll take a look at the quotient of powers. So the same way we did it when we multiplied the powers, when we had the product of powers, we're going to do here. We're going to set up this 3 to the 6th and write it out longhand. So instead of 3 to the 6th, we are going to write 3 times 3 times 3 times 3 times 3 times 3. That whole quantity over 3 squared, which is really just 3 times 3. So when I look here, I know that if I have a number on the top in the numerator that is the same as a number in the denominator, and I'm multiplying both things, then I can simplify. And I can say, well, 3 can go into 3 one time, and 3 goes into 3 one time. So that's going to cancel out. I'm going to do the same here for this set of 3's. 3 goes into 3, and 3 goes into 3 once, which leaves me with this, 3 to the first, 4 times, which is really 3 to the 4th power. And let's check it out on part B and see if this works for variables raised to exponents. b times b times b times b times b over b times b times b. So the same way that we work with numbers, we can work with the variables. b divided by b right here cancels out because that's going to equal 1. Same for these sets of b's and these sets of b's. So I'm left with b to the 2nd power. So let's think about how we could have gotten these rules just by looking at our exponents that we started with. I have a 6 here and a 2 here, and my final answer is 4. So if I'm thinking about it, 6 minus 2 is 4. Let's see if that works for b. I had a 5 and a 3, and my final answer was 2. So 5 minus 3 gives me 2. So now we can have a shortcut. We can have a rule that's going to work for everything. So let's say we have a to the x power over a to the y power. We can simplify by just subtracting the exponents and keeping the base. A to the x minus y power. Finally, we're going to deal with negative exponents. So these are a little tricky because a lot of people think, oh, it's negative, then I have to change the whole answer to negative. That's not the case here. What happens when you have a negative exponent is that it's going to flip your base. And when I say flip, I mean put the value that's in the numerator in the denominator and vice versa. So if we take a look at 5 to the negative third power, that's really 5 over 1. That whole quantity to the negative third power. So to take care of that negative symbol, what we're really going to have to do is we're going to have to flip that fraction. So instead of 5 over 1, we're going to make that 1 over 5, that whole quantity to the third power. Same deal over here with b. We already started off as a fraction here, and I see again I have that negative sign here for my exponent. The first thing you always have to do when you have that negative exponent is going to be to flip that fraction. So you're really finding the reciprocal of the fraction. That's what the negative does. So instead of 2 over 5, it's going to be 5 over 2, that whole quantity to the second power. So if we're talking about a general rule for these negative exponents, if I have b to the negative n, that's really going to equal 1 over b, that whole quantity to the n power. So just to prove our point about negative exponents, let's take a look at an example using numbers. So our general rule is up here at the top. B to the negative n is equal to 1 over b, that whole quantity to the n power. Or another way to write that would be 1 over b to the n power. So let's take a look here at b squared over b to the fourth. Let's set it up the same way we did before. B times b over b times b times b times b. So again, b over b cancels, b over b cancels, and I'm left with 1 over b squared. But if I use the quotient of power rules over here on the right for that same problem, b squared over b to the fourth, we would say 2 minus 4 is going to give me negative 2. So that answer is going to be b to the negative second power. So we started with the same problem on both sides, b squared over b to the fourth, and my final answers were 1 over b squared and b to the negative second. So what that really tells me is that 1 over b squared is really equal to b to the negative second, which is exactly what we tried to prove way up here in the top. One side note for negative exponents, if you have a problem like 2x to the negative 2, the only thing that's being raised to that negative is that x. So when you rewrite this problem, you would rewrite it as 2, because nothing has happened to that 2, over my x was in the numerator, and now it's in the denominator because of that negative symbol, and it's still squared. So be careful when you have negative exponents for just some of your terms and not all of your terms.